Welcome, dear civil engineering students. We perform a lot of experiments in our structural analysis laboratory, and I am Dr. Ramesh Babu from Galgotias University. Today we will see how to calculate the horizontal reactions in three-pinned arch and how to compare the values with the machine calculations. Now you can see that the aim is to determine the horizontal reaction, and there is not much complications because we are going to calculate only the horizontal reaction. So proceeding further, you can see that this is the experimental setup where you have the value of the span is around 0.5 meters span for this three-pinned arch, and the height of the arch is nothing but 0.1 meter. Now proceeding further, you can see that we have got two cases where this load W is applied at a distance LA from the left support, and this is the case number 1. Now you can see that this RC and RD should be equal and nullify the effect of each other so that they are in the opposite directions. Now we are going to calculate what is the value of RC or what is the value of RD. They are equal, and the first case is LA is less than 0.5 L. Now proceeding further, you can see that this is the case 1 calculation, and we find out that RC is equal to RD equal to W times LA by 2H, where H is the rise of the arch. Now you can see that this W loading is applied at a distance LA which is less than L by 2. So this distance is L by 2. As you see, LA is less than L by 2. So for that, you get a value of RC is equal to RD equal to WLA by 2H. Now proceeding further for the next case, you can see that this load W is applied at location LA which is greater than L by 2. So you can see that from here to here the distance is L by 2, and the W load is applied at a distance of LA which is greater than 0.5 L. So for this we get the reaction as W by 2H into L minus LA. Now this is the data acquisition system from the video software, where the student will enter the value of LA and he will enter the mass, and it will be converted to force as a load, and length is 0.5 meters and height is 0.1 meter. So after substitution of all these values, the student will be getting the reaction at this box. Now these are the calculations, tabulations where you have got load at these locations, and the student will write down the measured value of reaction at these places by the machine, and here he will verify with the manual calculations, and he will compare the accuracy of the machine as well as the manual calculations. Similarly, for the second case, for LE greater than L by 2, he is applying at 0.35 meter. He is increasing the load from 100 to 200 grams. So this is in gram, and it will be converted to Newton accurately. Then he will measure the RD using the machine, and he will compare the calculations of measured RD and with the manual calculations. So now for the reference of the students, I have derived the formula and I have explained how the formula is obtained. You can see that you take the whole arch, and first you apply that summation of moment at point B equal to 0. So in that case, it will be RA multiplied by the distance L minus W into the distance L minus LA is equal to 0. That we will see in the next slide. So you can see that RA times L minus W into L minus LA is equal to 0. From this you get RA is equal to W into L minus LA by L. Similarly, you apply the next equilibrium equation where RA plus RB is equal to W. Now you can see that RA plus RB minus W is equal to 0, and from this, after simplification, you get RB equal to WLA divided by L. Now you can see that RA is at this location and RB the value is W. RA value is W into L minus LA by L, and RB equal to WLA by L. Now, how to calculate the horizontal reaction? Let us take the first case where LA is less than L by 2. So you can see that this is LA which is less than L by 2. Take moment about the point C. So if you take moment about the point C, you can see that RA times L by 2 minus RC times H minus W into L by 2 minus LA is equal to 0. So from this you substitute the value of RA which was calculated earlier, and after simplification finally you arrive that RC equal to RT equal to WLA by 2H. Now here H is equal to 0.1 meter. So similarly you take the next case where you have LA greater than L by 2. So you can see that W is applied at this location, the weight is applied and it is at the distance LA, and you can see that this distance is nothing but LA minus L by 2. So from this you cut the left side half and you write on the equilibrium equations. You take moment about point C. So if you take moment about point C, you can see that RB times L by 2 is given here, which is going to create anti-clockwise moment, and RD times H is going to create clockwise moment, and W times this distance which is already noted as LA minus L by 2 will create clockwise moment. So equate this to 0 and finally you get RD equal to RC equal to W by 2H into L minus LA. So this is what you have for the RC or RD. So this is how we derive the horizontal reactions. Thanks a lot for watching, and if you have any queries, please mention in the comment section. Thank you.